Okay, today we will cover chapter 3, which is Polynomial and Rational Functions. Quadratic functions and applications. This is section 3.1. First of all, we already know what a quadratic equation is. A quadratic function is a function defined in terms of a quadratic equation. For the form of a quadratic function, f of x equal ax squared plus bx plus c. طبعا a, b, and c are real numbers. The real coefficient does not equal 0. This is called a quadratic function. We like to write quadratic functions in what we call the vertex form, and the form is f of x equal a times x minus h squared plus k. And we can do this by completing the square. We do this because this form will give us the vertex. We will see what the graph of a quadratic function is, and from this form we can find the vertex and the axis of symmetry for the graph, which we will call a parabola. Let's go back now to the form. Vertex form, f of x equal a x minus h squared plus k. The graph of the quadratic function is called a parabola. A parabola طبعا has a special point called the vertex. You can find it from the vertex form. h and k now defines the vertex. A parabola either points upward or points downward, and that can be determined by the sign of a. If a is greater than 0, then the parabola opens upward. Here the vertex will give you a minimum value. The minimum value for the function will equal to k, and that minimum of course occurs at x equal h. If a is negative, the parabola opens downward and the vertex now become a maximum. You will have a maximum value for the function equal to k. The maximum occurs at x equal h. The vertical line that passes through the vertex is called axis of symmetry. For the equation of the axis of symmetry is the line x equal h. We also, when we look at a quadratic function, we can find the x and y intercepts. The x-intercept will be the solutions of the equation f of x equals 0. You set the y value to equal 0 and solve for x. The y-intercept will be f of 0, the function evaluated at 0. Here is an example of quadratic functions, and we'll see how to write it in vertex form and find the vertex and axis of symmetry. F of x equal minus 2x squared plus 4x. The first thing we want to do is we want the coefficient of x squared to equal 1. So we would like to factor minus 2. Minus 2, open a bracket, then you will have x squared minus 2x, and leave a space to complete this bracket, plus 0. Plus 0 does not change the equation, but we will be adding something outside the bracket. Now we complete the square in the terms inside the bracket. We do it as usual. Take the coefficient of x, which in this case is minus 2. Divide it by 2, you get minus 1. Square that, you get 1. For inside the bracket, add 1 and subtract 1. Now the term that will be a perfect square will be x squared minus 2x plus 1. So we will leave this inside the bracket. We want to take the minus 1 outside the bracket, but remember it's multiplied by minus 2. So we take it outside the bracket as minus 2 times minus 1 plus 0. Now the quantity inside the bracket is a perfect square. You can write it as x minus 1 squared, and is multiplied in the outside by minus 2. Plus minus 2 times minus 1 is just plus 2. And now you have the function, the equation, or the function is written as in the vertex form. So this is now a parabola that has vertex equal 1, 2. And also the sign of A is just minus 2, where the sign is negative, where the parabola opens downward. That means the vertex will define a maximum. Yani the maximum value will equal to 2. The maximum occurs at x equal 1. The axis of symmetry is just x equal 1. Here is the vertex. Here is the graph of the vertex. This is the shape of a parabola. Because A was negative, the parabola points down. Here is the vertex, which is 1, 2. You can see that it gives you a maximum value. The maximum value for the function is equal to 2, and it occurs at x equal 1. Now we can also find the x and y intercept. For the x-intercept, set f of x equals 0. Solve this equation, minus 2x squared plus 4x equals 0. Factor minus 2x. You get minus 2x times x minus 2 equals 0. So x is either equal to 0 or x is equal to 2. So you have 2 points for the x-intercept, 0 and 0, and 2 and 0. And these are, you can see from the graph, and now these are the 2 points where the graph intersects the x-axis. These are the x-intercepts. The y-intercept is just f of 0, which is equal to 0. So the y-intercept is 0, 0. Notice that the same point, 0, 0, is a y-intercept and also an x-intercept. That is because this is where the x-axis and y-axis intersect, and the parabola, the graph of the parabola, passes through those points. But the same point is an x-intercept and also a y-intercept. You can find the vertex of a parabola without completing the square using the vertex formula. This is for the parabola f of x equal ax squared plus bx plus c. A doesn't equal 0. The vertex is given by this formula. The x-coordinate is minus b over 2a, and the y-coordinate is f of minus b divided by 2a. We will do this for this equation, f of x equal 2x squared minus 8x plus 1. This is a parabola. The vertex will be, the x-coordinate for the vertex is minus b over 2a, which is minus 8 divided by 2 times 2, which is equal to 2. This is the x-coordinate for the vertex. The y-coordinate is just f of 2, which is 2 times 2 squared minus 8 times 2 plus 1, which is equal to minus 7. This is the vertex, 2 and minus 7. By the way, for this parabola, the value for a is positive. This parabola is pointed upward, it opens upward, and this value 2 and minus 7, the vertex, defines a minimum value. The minimum value will be minus 7 at x equal 2. You might want to write the same equation, try to write it in vertex form, just to practice completing the square. You should get the same vertex. So far we looked at linear functions and quadratic functions. The general form of these functions is a polynomial function. This is how we write a polynomial function. N is a whole number, you take a finite number of terms, an minus 1, an minus 2, up to a0. These are all real numbers. The leading coefficient an does not equal 0. Here is a polynomial function. F of x equal an times x to the n power plus an minus 1 to the power times x to the power n minus 1. You multiply each of these terms is one of the coefficients multiplied by a power of x. The last two terms are a1 times x plus a0. This is called a polynomial function. The quadratic function is a special case, and the linear function is also a special case. This polynomial, we will say it's a polynomial of degree n. Here n is the highest power. Here is an example. F of x equal minus 3x to the power 5 minus 5x cubed plus 4x squared minus 7x plus 2. This is a polynomial of degree 5. This last equation, g of x equal 4 times the square root of x minus 3 over x, of course, is not a polynomial. A polynomial have only powers of x that are integers, positive integers. It does not include powers that are fractions or negative powers. G of x here is not a polynomial function. Next, we would like to define the zeros of a polynomial. طبعا a polynomial defined by y equal f of x. The zero of a polynomial is any value for x such that f of x equals 0. يعني the values in the domain that make f of x equal to 0. طبعا it is possible not to have any zero. It's possible to have 1 or 2 or any number of zeros depending on the polynomial. Another name for zeros is roots. يعني we say the zero for a function is the roots of the equation f of x equals 0. That means the same thing. Here is an example. Here this polynomial function is written as a product of terms, so it's easy to find the zeros. F of x equal minus 1/2 x squared times 2x minus 3 squared times x plus 2. The zeros in this case is 0, 3 over 2, and minus 2. These are the values that make f of x equal to 0. If you look at the graph of the function, 0 here, طبعا the number 0 is a 0 of multiplicity 2, لأن x squared, you can think of x squared as x times x, so you can think that the 0 is repeated twice. The graph touches the x-axis at 0, 0, as you can see from the graph. The next 0, which is 3 over 2, has multiplicity 2 because also the term 2x minus 3 is squared, it is repeated twice. The graph of the function also touches the x-axis at this point, 3 over 2 and 0. The third 0, which is minus 2, has multiplicity 1, and in this case the graph of the function crosses the axis, يعني the sign changes, the sign of f of x changes. A 0 can just only touch the axis, يعني the graph of the function might only touch the x-axis where you have a 0, or in the case of minus 2, the function crosses the axis. In this case, the sign of f of x will change. And if you look at an interval containing minus 2, you will see that the sign of f of x will change. That gives us طبعا, or lead us to the intermediate value theorem. And the idea here is that what if you want to know whether a function has a 0 in an interval or not? As we saw in the previous example, the sign of f of x changed when at one of the zeros the sign of f of x changes. The graph actually crosses the axis. The intermediate value theorem tells us that if the sign of f changes in an interval, then f will have a 0 inside that interval. In other words, if a is less than b, we are looking at the closed interval from a to b. If f of a and f of b have opposite signs, one is negative and the other one is positive, then f of x has at least one 0 on the interval from a to b. What that means is that the graph of f will cross the axis. If the sign changes, that means the function crosses the axis, so somewhere between a and b there must be a 0. It's possible to have more than one zero, but the intermediate value theorem guarantees that there will be at least one zero. Here is an example. The polynomial function f of x equal x cubed minus 2x squared plus 3x minus 8. This is a polynomial function of degree 3. This has at least one zero on the interval from 2 to 3. And to do this, we will show that f of 2 and f of 3 have opposite signs. If you evaluate the function at 2, you will get minus 2. The function evaluated at 3 will equal to 10. So f of 2 and f of 3 have opposite signs, and therefore, by the intermediate value theorem, f will have at least one zero between 2 and 3. Next, we would like to consider an operation on polynomials, and that is division. You can divide any polynomial by another polynomial, and you will get a remainder. You will get a quotient and remainder. Just like with numbers, you can divide any real number by a positive number and get a quotient and a remainder. Same thing for polynomials. And the best way to do this is using long division, and we will see at least one example of long division. It can be used to find the quotient, to divide two polynomials. Here is an example. If you divide 6x to the 4 plus x cubed minus 7x plus 1 by 2x squared minus x, you will get 3x squared plus 2x plus 1 plus the remainder minus 6x plus 1 divided by 2x squared minus x. For the result of the division, the quotient is equal to 3x squared plus 2x plus 1. The quotient is equal to minus 6x plus 1. You can check the details by using long division. We will look at an example for applying the long division. But anytime you know the quotient, whenever you carry out the division, once you know the quotient and remainder, you can always write the polynomial like 6x to the 4 plus x cubed minus 7x plus 1 can be written as the quotient times the divisor, which is the polynomial we divided by, plus the remainder. And it probably will be a good idea for you to check this. Multiply those two brackets and add minus 6x plus 1. You should get the original polynomial. But always, whenever you carry out the division, you can write the polynomial on top as the quotient times the divisor plus the remainder. Let's look at an example of long division. This is the same example. We are dividing 6x to the 4 plus x cubed. This polynomial does not have terms squared, so we have to add it. That will make the division easier. So we're just adding the term 0 times x squared minus 7x plus 1. Basically, we are taking 6x to the 4 plus x cubed minus 7x plus 1. We divide this by 2x squared minus x, and we're adding the missing term. The missing power here is x squared. We add it as 0 times x squared. The division, you take the first term, which is 6x to the power 4, divided by the first term, which is 2x squared. So the result will be 3x squared. Multiply 3x squared by 2x squared minus x. You get 6x to the power 4 minus 3x to the power 3. Subtract this from the original polynomial. The x to the 4 terms will cancel, and you will end up with 4x to the power 3. Now bring down the 0 term, the x squared term, which is 0 times x squared, and divide again. 4x cubed divided by 2x squared is just 2x. Multiply 2x by 2x squared minus x. You get 4x cubed minus 2x squared. Subtract again. The x cubed term will cancel, and you will be left with 2x squared. Now it's time to bring down the minus 7x, and carry out the division again. 2x squared divided by 2x squared is just plus 1. Multiply 1 by 2x squared minus x, you get 2x squared minus x. Now when you subtract, you will lose the x squared term, and you'll be left with minus 6x, and you have the 1 that you should bring down, and you have minus 6x plus 1. Here is طبعا you cannot go any further because in this last step you have x is to the power 1, which is lower than the polynomial you're dividing by. But this is the end of division. Right, and the result of the division, the quotient, is the polynomial on top. This is the quotient, 3x squared plus 2x plus 1. That is the quotient. The remainder is the linear term, which we obtained in the last step, which is minus 6x plus 1. يعني this is how you carry out long division, and you should be familiar with this from high school. If you forgot how to do this, probably it's a good idea to practice long division, and this is how you can divide polynomials and determine the quotient and remainder. Next we will see another method called synthetic division that can work only if you are dividing by a divisor of the form x minus c. We will look at the example 2. We want to divide 4x cubed minus 2x squared plus 5. We want to divide this by x plus 2. Now x plus 2, remember we are dividing by x minus c. C here is minus 2. Think of x plus 2 as x minus minus 2. C is just minus 2. Write minus 2 to the left and then just draw a line. And write the coefficients of the polynomial we are dividing, which is 4 minus 2. طبعا write 0 for the missing term, which is x. In this case it's x. لأن the cube term, the coefficient is 4. The squared term, the coefficient is minus 2. There is x to the 1 missing, so we use 0. And then the 0 term, the coefficient is equal to 5. Okay, here is now how synthetic division is carried out. Start by this first coefficient 4. You need to write it down under this long line. Start by writing 4. And then multiply minus 2 times 4, you get minus 8. Write it below the second coefficient, which is minus 2. And then add minus 2 plus minus 8 is minus 10. And multiply again minus 2 times minus 10, which you get 20, and write it under 0. Add the two terms, you get 20. Multiply another time, minus 2 times 20 is minus 40. Now you write this under 5. Add 5 plus minus 40, you get minus 35. This number you get in the last step is the remainder. Now remember, you are dividing by a linear term, by x minus c. The last step, the remainder will always be a number. Then the power will be 1 less than the term you're dividing by. In this case now minus 35 is the remainder. Here طبعا you might want to use long division to carry out the division. You will find out that you will have طبعا this not only gives you the remainder, which is minus 35, but the coefficients will be, the quotient will be those numbers, the last line will give you the quotient as well. Here these are the coefficients now for the quotient. The quotient will be 4x squared minus 10x plus 20, and this last number here is the remainder. The last line will give you the quotient or the coefficient of the quotient, and then the last number will give you the remainder. But now remember, this works only if you're dividing by x minus c. طبعا it may not be a bad idea to try it both ways, to practice long division, and also synthetic division is easier if you're dividing by x minus c. We also have some theorems that makes it we will find out what does it mean for a polynomial to be divided by a linear term. This is called the remainder theorem. If a polynomial is divided by x minus c, then the remainder is equal to f of c. Here you can actually find the remainder without carrying out the division. In our example, f of x equal 4x cubed minus 2x squared plus 5. If you want to know the remainder by dividing okay, this is an example 2. We divided by x minus 2 or x plus 2. You can actually find the remainder without carrying out the division. Just evaluate the function at minus 2. If you evaluate f at minus 2, you will get minus 35. طبعا احنا in the previous example we actually carried out the division. We divided 4x cubed minus 2x squared plus 5 by x plus 2, and the remainder was minus 35. The remainder theorem is useful if you just want to know the remainder. That doesn't tell you the quotient. If you want to know the quotient, you have to carry out the division, either use synthetic division or just use long division. But the remainder theorem will give you the remainder of dividing the function by the linear term x minus c. We also have the factor theorem. F of x here is a polynomial. If c happens to be a 0, if f of c equals 0, then x minus c will be a factor. طبعا x minus c is a factor. What does that mean? If you divide the function by x minus c, the remainder will be 0. Here is another useful theorem called the factor theorem, that if f of c equals 0, then the polynomial function f of x is divisible by x minus c, or that x minus c will be a factor, or f of x. The opposite is also true. The reverse is also true. If x minus c is a factor, then f of c equals 0. Now remember, now f of c will give you the remainder. If x minus c is a factor, that means f of x is divisible by x minus c with the remainder equals 0. In other words, by the remainder theorem, f of c must equal to 0. Here is an example. طبعا we can verify in x minus c is a factor of x cubed minus 7x minus 6. And you can verify this in two ways. Either show that f of 3 equals 0, and therefore by the factor theorem, if f of 3 equals 0, then x minus 3 will be a factor. And if x minus 3 is a factor, then also we know that f of 3 equals 0. The other way to do it without using the factor theorem is to actually carry out the division, divide x cubed minus 7x minus 6 by x minus 3, and you will find out that the remainder will be 0. This is all these formulas or theorems are useful if you are if you want to know if you want to factor a polynomial. Anytime f of c equals 0, when you have that's in fact why we try to find the zeros for a polynomial. You can use them to factor the polynomial. F of c equals 0 means x minus c is a factor. It means that when you divide f of x by x minus c, the remainder will be 0. All those things mean the same thing. In section 3.6, we will consider polynomial and rational inequalities. First, polynomial inequality. If f of x is a polynomial, then the following inequalities are called polynomial inequalities. Either f of x less than 0, f of x greater than 0, f of x less than or equal to 0, or f of x greater than or equal to 0. These are all called polynomial inequalities. Now, rational inequalities, f of x now is a rational expression for f of x less than 0, f of x greater than 0, f of x less than or equal to 0, or f of x greater than or equal to 0 are called rational inequalities. In this section, we will see how to solve both polynomial inequalities and rational inequalities. Here are the general steps to solve nonlinear inequalities. The first step is to express the inequality in one of these forms that we mentioned, either f of x less than 0, or f of x greater than 0, f of x is less than or equal to 0, or f of x greater than 0. Now, the real solutions to the related equations, solve f of x equals 0, that will give you the boundary of the solutions. You want both the solutions to the equation f of x equals 0 and the points for rational inequalities. You want the points where f of x is undefined. These will give you the boundaries of the solution set of an inequality. Then determine the sign of f of x on the intervals defined by the boundary points. The sign of f of x will change in those intervals which are determined by the boundary points. Now, for f of x, if f of x is positive, then the values of x on the intervals, on that interval where f of x is positive, will be the solution for f of x greater than 0. If f of x is negative, then you're looking for the intervals values for x that makes f of x negative will be the solution to f of x less than 0. But you still have to check the boundary points to see if they can be included in the solution set or not. In the last step, you can write the solution. The steps, like many things we do, just reading the steps may not be very clear. All these steps will be clear when we do an example, which we will do in the next slide. Here is an inequality. This is a polynomial inequality. We want to solve minus 3x times 2 minus x times x plus 4 squared less than 0. So what we want to do, here the solutions, the zeros for this expressions are minus 4, 0, and 2. These are the boundary points. So what you want to do is check the sign. These 3 points define 4 intervals from minus infinity to minus 4, from minus 4 to 0, from 0 to 2, and from 2 to positive infinity. We want to write each term in the inequality and see the sign in each interval. And check the sign for the product, and that will tell you we want to find x where the product of those terms is negative, less than 0. That will be our solution set. If I start with the first term, which is minus 3x, minus 3x will be 0 at 0, but for negative values, it will be positive. For the interval minus infinity to minus 4 and minus 4 to 0, this term will be positive. For any value greater than 0, minus 3x will be negative. For the second term, 2 minus x, this will be 0 at x equal 2, but it will be positive for x less than 2. It will be positive for the intervals to the left of 2. It will be negative for x greater than 2. The next term, because x plus 4 is squared, it will be positive everywhere in all of the intervals. Now, what about the product of those terms? In the first interval, which is minus infinity to minus 4, everything is positive, where the product is positive. Same thing for the interval from minus 4 to 0. Every term is positive, where the product is also positive. But let's look at the interval from 0 to 2. We have the first term is negative. The second and third terms are positive, where the product will be negative. The final interval from 2 to infinity, you have negative times positive. The result will be positive. For the product, this term here, is negative only in the interval from 0 to 2. So that's my solution set. طبعا 0 itself will also 0 will not be a solution لأن 0 is not less than 0. So 0 is not included, and also x equal 2 is not included لأن it will give you 0 on the left hand side. So then the solution set in this case will be the interval from 0 to 2. These are the values that makes the expression negative. Here is now an example of solving a rational inequality. X minus 4 divided by x plus 2 greater than or equal to 0. Remember, we're looking for the zeros of each expression and also the values where the term is undefined. فthere is طبعا x equal 4 is a 0, and minus 2 is a value where the term is undefined. These are the boundary points. We now have three intervals from minus infinity to minus 2, minus 2 to 4, and 4 to plus infinity. Now for values less than minus 2, for example, try minus 3, the expression will be f of x طبعا will be negative divided by negative, so the expression will be positive. For f of x is greater than 0. What about between minus 2 and 4? Here you can try 0, for example. So you get minus 4 over 2, you get a negative number, and f of x is negative. For the third interval from 4 to infinity, try x equal 5. F of 5 is equal to 1 divided by 7, which is positive. So now we want the interval where the term is greater than or equal to 0. There is two solutions. The first interval is from minus infinity to minus 2. That's where the term is positive. Also from 4 to plus infinity, the term is positive. What about the boundary point? طبعا the boundary point, if you substitute minus 2, minus 2 is excluded because the function will be undefined. Yani minus 2 here will give you an undetermined amount. So minus 2 is not included. Now what about 4? 4 is okay, and 4 will give you 0, and 0 is greater than or equal to 0. So here is now my solution set. The open interval from minus infinity to minus 2, union the closed interval from 4 to infinity. The last section we will study variations. There is three types of variations: direct, inverse, and joint variation. In those, in all cases here, k is a non-zero constant real number. The following statements are equivalent. Now we're working with two variables, x and y. We will say that y varies directly as x, or y is directly proportional to x, if you can write y equal k times x. This is direct variation. Y varies directly with x, or y is directly proportional to x, if you can write y as k times x. Y varies inversely as x, or y is inversely proportional to x, if you can write y as k divided by x. The third case, y varies jointly as w and x, yani the variable y varies jointly as w and x, or y is jointly proportional to w and x, if you can write y equal k times w times x. If k in all those cases are a constant, it is called the constant of variation. For direct variation, if you can write y as k times x. Inverse variation, if you can write y as k divided by x. And y jointly, the variation is joint with w and x, two other variables, if y can be written as k times w times x. In all these situations, you will be given values for x and y, or in the case of joint variation, you'll be given values for the variables that will help you determine k. Once you determine k, you can write the relation, and that will describe the type of relation between the variables. How do you solve an application involving variation? The first step is to write a general variation model that relates the variables given in the problem. K represents the constant of variation. The way to find k, and that's the key, and once you find k, first of all you have to select the correct type of variation, and in all cases you are trying to find k. Solve for k by substituting known values of the variable into the model from step 1. Step number 3, substitute the value for k into the original variation model from step 1. Then the result will give you your model. Use the variation model from step 3 to solve the application. Here is an example. This is example 3, solving an application involving direct variation. The amount of an allergy medicine that a physician prescribes for a child varies directly as the weight of the child. Clinical research suggests that 13.5 milligram of the drug should be given for a 30-pound child. How much should be prescribed for a 50-pound child? This is part A. And part B, how much should be prescribed for a 60-pound child? First of all, we already know that this is direct variation. Part C, we want to know, a nurse wants to double check the dosage on a doctor's order of 18 milligram for a child of what weight in this dosage. If you know that the dosage is 18, then what should the weight be? All of this, once you find the value for k, then you can solve, you can find the proper dosage for any child, any weight, and also if you know the dosage, then you can find out the weight of the child from the model. First of all, this is what we will do now. The steps is to here is how we solve the problem. First, we label the variables. The variables are the amount of medicine and the weight of the child. So let A represent the amount of medicine, and let W represent the weight of the child. We know that A and W vary directly, so we can write A as equal to K times W. Next step, we substitute the known information, the known values for the variables to find K. We know a child that weighs 30 pounds is given 13.5 milligram. So when W is 30, A will be 13.5. Substitute that in my model. Now K is equal to 13.5 divided by 30. K is equal to 0.45. Now my model will be, substitute the value for K. The model will be A equals 0.45 times W. The amount of medicine you give to a child is equal to 0.45 times the weight of the child. And now you can solve the problems that were stated in the problem, in the example. For example, if you have a child that weighs 50 pounds, the amount of medicine you give him is 0.45 times 50, which is 22.5 milligrams. The other one, I think, was 60 pounds. The amount of medicine you give to a 60-pound child will be 0.45 times 60. And this is an equation. The model is an equation. If you know the amount of medicine and you want to find the weight, just substitute the value for A, the amount of medicine, and solve for W, and that will give you the weight of the child. Next, we would like to look at an application involving inverse variations. The loudness of sound measured in decibels, or dB, varies inversely as the square of the distance between the listener and the source of the sound. طبعا it makes sense that the farther away you are from the source of the sound, the less the loudness is. بس طبعا here the loudness is inversely related to the square of the distance between the listener and the source of the sound. فإذا we have inverse relationship between the loudness and the square of the distance. طيب, if the loudness of sound is 17.92 decibels at a distance of 10 feet from the stereo speaker, from the source of the sound, what is the decibel level 20 feet from the speaker? Here the data we're given is that when the distance is 10 feet, the loudness is 17.92. But طبعا from these two numbers we will figure out K, the constant of variation. We write our model, and then we can use it to solve problems like finding what the loudness will be if you are 20 feet away from the source of the sound. طبعا our model is an inverse variation model, so we can call loudness L and the distance D. The loudness is inversely related to the square of the distance, meaning L equal K divided by D squared. Now we use the numbers we are given. When the distance is 10 feet, the loudness is 17.92. If I substitute that in your model, you have 17.92 is equal to K divided by 10 squared, or طبعا K divided by 100. If K is equal to 100 times 17.92, so K is equal to 1792. Write this in the model we started with. L is equal to 1792 divided by D squared. Now with this model you can answer the other question. What is the loudness when the distance is 20 feet? Just substitute 20 for D. Then now that we know the model, at 20 feet the loudness will be 1792 divided by 20 squared, or 4.48 decibel. Here in comparison, remember the loudness was 17.92 at 10 feet, when the distance was 10 feet. When you double the distance to 20 feet, the loudness decreased to 4.48. This is consistent with the inverse relationship. طبعا it is an inverse relationship with the square of the distance. For K greater than 0, as one variable increased, the other one decreased. طبعا the relationship gives you how much the first variable decreased when the second variable increased. But this is an example now of inverse variations. Here is the third type, which is involving joint variations. The kinetic energy of an object varies jointly with the weight of the object at sea level and the square of its velocity. The energy is jointly, you have joint variation with two things: with the weight of the object and the square of its velocity. During a hurricane, a 0.5 pound stone traveling at 60 miles per hour has 81 joules. The energy is 81 joules of kinetic energy. Suppose the wind speed doubles to 120, find the kinetic energy. Now you have joint variations. We will do the same steps. We will first label the variables, then use the joint variation model, and find from the given information we find the value for K, and that will give us the model. And from the model you can calculate any quantity that you want. But let's just remember here the information. Well, first of all, we have joint variation. Okay, the energy is jointly, we have joint variation with the weight and the speed. a half pound stone, يعني when the weight is half a pound and velocity is 60 miles per hour, the energy will be 81 joules. Let's use this information to find K. طبعا the first step is to select the correct model. The energy, you have joint variation with the weight and the square of the velocity. E, the energy, is equal to K times W times V squared. For a stone that is half a pound in weight, when the velocity is 60, the energy was 81. Substitute 81 for the energy, 0.5 for the weight, and 60 for the velocity. From that information, طبعا you can solve for K. K will be 0.045. You can now substitute the value for K in the model, and now we can use it to answer the question. طبعا now the model will be in the energy is equal to 0.045 times the weight, W, times the square of the velocity, V squared. Now we want to know the energy if the speed doubles to 120. طبعا the weight of the stone is still the same. Substitute 0.45 for the weight and substitute 120 now for velocity in that model. The energy now will be 324 joules. The kinetic energy for a pound that weighs half a pound traveling at 120 miles per hour will be 324 joules. Okay, here is a skill practice. The amount of simple interest earned in an account varies jointly as the interest rate and the time of investment. طبعا the interest rate will vary depending on the amount of interest you earn. Depends on two things, on the interest rate and how long you leave the investment. Then the simple interest rate varies jointly with interest rate and time. If you have an account that earns $200 in 2 years at 4%, how much interest would it earn in 3 years at the rate of 5%? That means when the interest is $200, the time is 2 years and the rate is 0.04. We want to know how much interest we'll get if the time is 3 years and the rate is 5%. First of all, we write the model for joint variation. Interest, which is I, equal K times R times T. Here طبعا I is interest, R is the rate, and T is time. We know that when T is 2 and the rate is 4%, يعني 0.04, the interest is 200. If I substitute that in the model, then 200 equal K times 0.04 times 2. K is equal to 200 divided by 0.04 times 2, which is 2,500. Then now you substitute it back. طبعا K will turn out to be the principal. Here now substitute the value for K. The interest is equal to 2,500 times R times T. How much interest then you'll earn if T is 3 years and the rate is 5%? طبعا T is equal to 3, R is equal to 0.05. Substitute those numbers in the model. The interest will be 2,500 times 0.05 times 3, it's equal to $375.